Hello? Hi everyone. Today we will continue to look at the content of HCIA-Storage. Today we will specifically introduce how data storage in our memory is actually carried out. For example, you can think about it. How are the photos and videos on your phone remembered? Because what do we actually not have in our phones? We don't have mechanical hard drives, right? And there's no room for such large mechanical hard drives. In the case of phones, how is it actually done? Through a small storage chip. That is through our NAND flash. Using such a storage chip to save our data. In memory, we mainly use NET flash. For storage, and what does it primarily use? It uses floating gate transistors to store data. The main principle is through what? By using whether there is a charge stored on the floating gate or the amount of charge stored, to change the threshold voltage of the transistor. By reading the threshold voltage of the transistor, we achieve the representation of data, information. This method of storage is completely different from that of mechanical hard drives. Memory storage is quite unique, for example, memory itself. The storage in solid-state drives is also quite special. In our phones, the storage is often referred to as memory, but it actually can be considered a type of hard drive. It stores our data in a manner similar to solid-state drives. So what about us as a whole, R1? The structure is as follows. Including several components. First, the component called LUN is the smallest physical unit that can be independently encapsulated. It usually contains multiple plans. Among multiple plans, each plan is equivalent to having what? It will have independent configuration registers. Typically speaking, each LUN contains approximately 1,000 file units, or even as many as 2,000 units. Blocks, or even numbered blocks. These organized components, what are they to each other? They are interconnected, but what exactly is the relationship between them? Actually, if I explain it using technical terms, it might be hard for everyone to understand. So, let me use an analogy here. First, our LUN is equivalent to a library. It can be compared to a library, and within this library, there can be multiple bookshelves, which are the plans, and each bookshelf is divided into multiple cabinets, which are our blocks. The cabinets are further divided into many different what? Different drawers that store many books, and the books are our configurations within the configuration. Each page, when written, has a minimum unit size of about 4K. Finally, the cells are our smallest storage units, equivalent to each word sorted. For storage, it's done through zeros and ones, and this is our overall structure, from large to small, from the bookshelf to the cabinet, to the drawer, to the book, to each individual word. This is ours. The overall composition of our internal storage units in NET flash. The professional terminology, actually everyone can take a look and just get a basic understanding. The main thing is to understand their overall structure, which is nested from large to small, one inside the other. This is our overall composition, which is the composition of a storage unit in our solid-state drive. Here, our main operation. What is the primary task of our storage? What does it mainly include? The core operations primarily include 3 types: erase, program, and read. Erasing is equivalent to clearing the entire block. It requires applying a high voltage current, which takes a relatively long time, usually about 3 milliseconds. The second operation, programming, involves writing data into our configuration, or in other words, into the book. This requires precise control of the charge. The third operation, reading, involves detecting the charge state of our smallest cell, and this process is very fast. It takes approximately 50 microseconds. This is our overview. The main overall operation is what we do. A basic operation of the storage units in a solid-state drive. Of course, it's important to note that our erase-write process will affect us. It causes some damage to the insulating layer of the flash memory transistors. After an erase or programming failure, it will mark the block as a bad block. Manufacturers generally define that when the number of bad blocks reaches a certain level, around 4%, they consider the solid-state drive to have reached its lifespan limit. Of course, it's not accurate to say the solid-state drive has reached its lifespan limit. More precisely, it's our storage units have reached their lifespan limit. Of course, since our storage units are primarily responsible for the storage of our solid-state drive, once they reach their limit, the lifespan of the solid-state drive is also nearing its end. This is one of our basic storage unit structures. Next, we will mainly take a look at these storage units. What technologies are there? What types are there? There are a total of 4 types. SLC, MLC, TLC, and QLC, these 4 types. First, let's briefly introduce them. The first type, SLC, is like each room can accommodate 1 person, making it relatively simple to identify and fast. For MLC, each room can accommodate about 4 people. 4 people. The capacity will be slightly larger. Here. How do you distinguish between 1 person and 4 people? It's like this. SLC is equivalent to storing 0 and 1. As for MLC, it's equivalent to accommodating 4 people. The arrangement between 0 and 1 is 0, 0, 0, 0, 1, 10, and 11, making a total of 4 combinations. When it comes to TLC, with 3-digit combinations, there are 8 different possibilities, so it accommodates 8 people. As for QLC, it accommodates 16 people. Here, there are 4 types, each with some differences. Let me briefly introduce them to you. The first type is where only 1 person stays in a room, making it relatively simple to identify and fast. Its advantages are long lifespan and fast read speed. The downside is that the capacity is relatively small and the cost is high. This type is generally used more in enterprise-level solid-state drives, as enterprises tend to use solid-state drives more frequently. The lifespan is relatively long, right? Long lifespan and fast speed are very important features. When it comes to MLC, the capacity is essentially doubled. And for us, the cost is relatively reduced as the capacity doubles. The downside is that it has one. The speed will be slightly slower, and the lifespan will also be shorter. The lifespan will be somewhat shorter. And when it comes to TFC, the capacity increases again. How does the capacity increase? Just look at these 4 cylinders, and you'll understand. Looking at these 4 cylinders, they are gradually increasing. Here, about 33% more capacity is added, and the price is relatively affordable. Generally, this is used in phones or USB drives, which is a commonly used TLC technology. However, the downside is quite obvious, which is its lifespan is very short. It can only be erased and written 500 times, and, for example, the first SLC can be erased and written 100,000 times, the second one 3,000 times. For the third one, it's only 500 times left. Finally, the last one, QLC, the capacity increases. Again, the capacity increases once more. It's more suitable for our cold data storage, such as writing logs, surveillance videos, and so on. The downside is that it can only be erased and written 100 times, and the write speed is also relatively low. Overall, there are actually 4 different technologies, and the capacity gradually increases, the speed gradually decreases, of course, the price also gradually decreases, and the lifespan gradually decreases as well. This is the overall distinction among them. The first type is mainly suitable for aerospace and military industries. The second type is more suitable for enterprise databases. The third type is mainly suitable for consumer electronics and everyday products. And the last type is more suitable for archival storage and cold storage. This is our overview. The composition of solid-state drives, the unit structure, and the various technologies they employ. We'll end this lesson here. If anyone needs to learn Washington technology or wants to obtain the Washington Question Bank, please send me a private message or leave a comment below the video for discussion. That's all for today. Goodbye, everyone.